everyone. Welcome to another lecture of engineering statics, and today we are going to start today's lecture about moment. And this is going to be an introductory lecture in order to understand the basic definition, the basic concept and idea of what moment is. And by the end of today's lecture, you'll be able to solve different sort of numerical problems under the category of moment. So without any further ado, let's start today's lecture. Okay, so basically what moment is nothing but just a kind of, you can say, a rotational impact that is being produced in any object or in any body or any system under the influence of some external force, right? So moment is basically a tendency to rotate a body about any particular axis. For example, for the purpose at hand, if you look closely to this picture, this is a pipe, right? And this is a wrench. So if a force is being applied on this wrench, so in response of this applied force, this wrench will produce a rotating impact in this pipe. And if I apply more force, so consequently, the more rotational impact will be produced in this body. For the purpose at hand, this is a pipe. So the moment is basically relying on the amount of force that is being applied and the distance along which the force is being applied to any system. So if we go in more detail of the moment, so what is rule of thumb? That if you curl your hand as shown in this figure, so your curling of finger will represent the direction of the force and the thumb will point out in the direction of movement like this. See, so the moment that is being produced under the influence of some external force, it will always be orthogonal or perpendicular to the plane in which force is being applied. So you may use any of the convention as mentioned in this slide, whether you can take counterclockwise moment as positive and clockwise moment as negative, or vice versa, which means you may take counterclockwise as negative and clockwise as positive. So both of the conventions may be used. So what's more important in finding a moment is that, as I already told you, that moment is basically the product of the force that is being applied and this d. This is not an ordinary distance. This is basically moment arm, and a moment arm has always to be an orthogonal or perpendicular distance from the point about which you are interested to find out the moment. For example, let's suppose if I say that you have to find out the moment about this point A, right? And you have a point of application of force somewhere right here. See? So the line of the action of this force would be something like this. If I draw the line of action of the force, it would be something like this. So the distance between the line of the action that is being passing through this point of application of this force to the point about which you have to find out the moment. This perpendicular orthogonal distance would be known as moment arm, and this is what you have to multiply the external applied force with that moment arm in order to find out the moment. So one thing that you need to be understood that this D, or somewhere in some books you will see the notation as R. So this R or D should be the moment arm. It has always to be a perpendicular distance, right? So while solving the numerical problems, you need to be very careful about finding out this moment arm. So if you expand this moment arm formula, that was F into D, or you may see in some of the books as F into R, this is basically a cross product, right? So when you open up a cross product, you have to introduce the sign of that particular angle, right? So you may write in terms of angle as F into R, sine of that particular angle, right? So how you are going to use this notation in while solving different sort of numerical problems while writing R cross F, this is something that we are going to study in our upcoming slides, right? Because there is a proper rule of thumb in order to open up this cross product. So we are going to see this concept in a bit detail in our upcoming slides. So here it is. So let's say you have a problem like this where you have some external force, because the curling of the finger denotes the direction of the force, and obviously, as I already told you, that the consequently produced moment will always be perpendicular to the plane. So what you need to be remembered is that please look closely to this picture. You need to follow this convention, right? This is an anti-clockwise rotational direction. So whenever you have to multiply I cross j, you will get a positive k, right? So you are following the anti-clockwise direction. Likewise, if you have to multiply j cross k, it will always be a positive I, like this. Likewise, if you have to multiply k cross I, you have to get plus j. But what if I ask you to multiply I cross k, which means now you are moving. Let me just erase all this so that I can explain you the converse of this. Okay. So previously we have discussed the anti-clockwise, yeah, counterclockwise direction, right? But let's say I ask you to find out the clockwise direction. So in this case, let's suppose if I ask you to multiply I cross k, the clockwise direction, so you will get a negative j, something like this. So this is what you need to be remembered while solving the numerical problems, that whenever you come across a situation where you have a force component or the moment arm component along the I-axis, right, and along the J-axis, so the cross product of I cross J will always give you K. And if you are going in the other way around, the opposite direction, for example, I cross K, then you have to write minus times J. See, so this is something that you need to be remembered by solving the numerical problems to find out the moment. Okay, so we know that cross product will give you the k, I, or j consequently when the angle between any of these axes, whether I, j, or k, has to be 90 degrees, right? So the moment when these axes or any of these two axes becomes parallel to each other, or ultimately you may say that the angle between any of these two axes becomes 0, which means sine of 0 will become 0. So in that case, you will get 0. So I cross I, which means if let's suppose I say that this is x-axis, right, as mentioned on the screen or on the slide, the unit vector along the x-axis is I. See, so if you get another axis parallel to this x-axis, so both of the axes will make 0 angle, right? So sine of 0 will give you 0. So I cross I will always give you 0. Likewise, same strategy applies to j cross j, k cross k. See, so in case of cross product, the cross product between any of the same axes, or you may say that any of the parallel axes, will always give you 0. So it's a must-have condition that they both should be of different. For example, I cross j or j cross I, or k cross I or j cross k, or something like this. See, so this is something that you need to be very careful about while solving the numerical problems. Okay, so let's have a look on this numerical problem. So I'm gonna read what this problem statement says. So it says that you have to calculate the magnitude of the moment about the base point O of the 600 Newton force. So this is base point O, right? You have been asked to find out the moment about this base point O, and but you have been given a force having magnitude of 600 Newton force. So this is the force having a magnitude of 600 newtons, and you have always been given the direction as well, which is 40 degrees. So this means that you have to find out the resolution of this force. You cannot simply solve by multiplying the 600 Newton force with the moment arm, right? So now you have the force which is being inclined, and the angle of inclination is also been given, that is 40 degrees. So let's see how you're going to resolve this 600 Newton force into its consequent components. Okay, so this is the picture that was given to you in the question, right? So this is the consequent picture that you have to draw, and you have to resolve the 600 Newton force into its components. So you may see that this is the 600 Newton force. So this component, if I take this as your, by default standard axis. So this is your x-axis and this one is your y-axis. So the component that is being resolved along the x-axis, it is basically the 600 cosine of that angle, and we already know that the angle is being provided to us is 40 degrees. See, so the component of the 600 Newton force along the x-axis may be written as 600 cosine of 40 degrees, right? Okay, that was one component of this force. So if I ask you to resolve this component of the 600 Newton force along the y-axis, so it could be 600 sine of that angle, which is 40 degrees, right? So now you have the forces along both of the axes, x-axis and y-axis. What else you need in order to find the moment is the moment arm, right? So what you need to do is, now you have actually two components. So ultimately you have to multiply these two components with two moment arms in order to find out the cumulative impact of the force about this point O to find out the moment. See, so let's start solving for this. Let me just first raise all this so that I can explain with more comfort. Okay, so let's start with this, the force component that was along the x-axis. So this is 600 cosine of 40. So now if you draw the line of action of this force, it would be something like this. If I draw this dashed line, right? So this is the direction of the force. Now you have to look very closely that what is the moment arm distance. Okay, so what I have told you, that moment arm distance has to be the perpendicular or orthogonal distance from the point about which you have to find out the moment and to the point of application of the force. So you may easily see that this is the line of action and this is the point where you have to find out the moment. So this 4-meter distance is the vertical distance, which means in this particular case your moment arm is 4 meters. So you may write it as 600 cosine of 40, which has been calculated already, and this gives you 460 newtons, right? So you have to multiply 600 cosine of 40 or 460 with moment arm, which is 4, right? So this is the moment that is being generated with this x-axis component of the 600 Newton force. Now we are left with another component of the 600 Newton force, that is the vertical component, and that is 600 sine of 40, right? So in this particular case, once again, just let me raise all this so that you can easily understand. Okay, so now we are interested in this vertical axis force. So if I draw the line of action of the force, it could be something like this. See, the vertical dash line, and the moment that you have to be found out about this point, which is O. So distance from this point O to the point of application of the force, and if you draw the line of action that passes through the point, something like this, so this distance has to be the moment arm distance, which is basically an orthogonal distance, which is at 90 degrees. So when you will be writing the moment that is being generated under the influence of the 600 sine 40 newtons force, so you may write it as 600 sine 40, or you may write it as 386 multiply by this 2. Why? Because this 2 meters is the moment arm distance for the case of this vertical component of the force, right? So now you have the force component that was along the x-axis, you have the component of the force that was along the y-axis, you have the corresponding moment arms. Just multiply them and add them, and you will get the final answer of this moment, like this. So that was a kind of introductory lecture. We will be back once again with more of this moment lectures. So still then, Allah Hafiz and take good care of yourself.